in last video, I was just plugging these values into my calculator. So let's continue this from here. Uh, so I saw something while I was plugging this thing in, is this. When I look at this, how many times 0.015 has occurred in my probability? It's just only one times. Okay, instead of writing it individually onto my calculator, which will take a quite long time, uh, uh, so what I've done, I have looked at it how many times each of these probability has occurred. So I don't need to just calculate one time and then multiply it by 2. So this is what I have done. So let's say A has occurred only one times. There's only one times. There's like 5 of these A's. All right, so this is only one time, which has a probability of 0.15. So I have to write it. But how many times I get 0.12 probability? 1, 2 times. So what have I done? I just calculated I have just plug in the value of this, and then whatever the answer I got, I just simply multiply by 2 with ignoring negative sign. I'm going to bring that negative sign later. Same thing, I looked at it and I said how many times 0.06 has occurred in my frequency analysis table. So this has occurred 1, 2, 3, and 4 times. So what I did is just calculated one time, and whatever the answer that I got, I actually multiply that by 4. Okay, so what I did, so how many times 0.06 has occurred? The probability, it has occurred 1, 2, 3, 4 times. So what I did, I just plugged in one time into this formula, ignoring my negative sign, and whatever the answer that I got, I just multiplied that by 4 and brought that negative in, whatever the answer was, and then I'm gonna use this negative later. Then same thing I did it here. How many times 0.03 has occurred? It has occurred 1, 2, 3, 4, 5 times. So I just calculated once, and whatever the answer I got, I multiply that by 5. And in this way, I got all these probabilities for these numbers, which are right here. Instead of plugging individual one of these, I just calculated once, and then I just multiplied however many number of times this probability has occurred. I just multiplied that number of times. So for the first one, there's only one time 0.15 has occurred, so the answer was negative 4.10. For 0.12, it has occurred twice, so when I multiply whatever the answer I got with 2, I get negative 0.73. So far for 0.06, it has occurred 4 times, so I just calculated once and then just multiplied the answer by 4, and I got negative 0.97. Same thing for 0.09, it has occurred 2 times, 1 and 2, so I just simply multiplied that answer by 2 once I calculated once. And same thing, this has occurred how many times? 5 times. 1, 2, 3, 4, and 5. So I just simply calculated once, and then I just multiply that by 5, and this is what I got. So the next part is just simply plugging in this value, because there is a summation sign, plugging these values in, plug all of these values in, and then submit them. All right, so once I do that, here's what I did. Here's what I did in my calculator. Okay, so if you were to look at it, this negative sign in my calculator is actually this negative sign, which is coming from the equation. All right, so this is this positive sign, so I can also put that in parentheses as well and bring that negative. How about that? Okay, so 0.1410 plus 0.73, negative 0.73, because I need to summate them, plus minus 0.97 minus 0.625 plus 0.758. So once I hit enter, I got my answer to be 3.493. 3.493. I hope I'm doing everything right. I didn't make any mistake, but if I did, just let me know in the comment section in my calculation. So once I do that, the answer that I got is 3.49. So what that answer is this. I need so my entropy for this came out to be, so h of x is 3.493 bits. What that means is this, that I can represent this entire line using 3.493 bits. I can represent, and based on these number of bits, I can design efficient codes, which were like Huffman codes were the first one, and there's then Lempelzif, and it's sort of like compressing it without losing the integrity of your message. You can use minimum number of bits to actually transmit the same thing, while if you have to transmit them individually on your computer system. So for example, in a normal computer system, A might have some ASCII representation. Let's just call it that representation to be, hypothetically, let's say 54. If I want to represent that 54, I need 8 bits. So for all of these individual letters, without compression, without using these technique, I have to send 8, 8, 8, 8, 8, and it will take long amount of time. But using Shannon entropy, and using, based on Shannon entropy, these source coding algorithms, I can actually transmit in a lesser bit same information. So I hope you like this small tutorial on information theory and Shannon entropy. And if you have any question, please leave it in a comment section, and do let me know if I made any mistake. Which I don't think so I did, but you never know. But the idea is this. So don't forget to subscribe to my channel, and if you have any questions, please leave it in a comment section.